Hey everybody, this is Larry. This is day 21st of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Today I ran about 11 miles. Actually, I felt very, it was supposed to be easy, 11 miles, and I kept it easy. But I felt very refreshed still afterwards. I probably could have gone longer, but I was meeting up with a buddy. So today we'll get to do this farm pretty okay. That said, as I've complained about the last couple of days, the thing with binary search farms, like one of the tricky part about it is identifying binary search farms. And as a result, it does take a little bit out of the problem solving skill, for binary search, which is just recognizing that it is a binary search problem, right? So I don't know. I haven't seen this problem yet. We'll take a look. We'll see what kind of problem it is. And if it's binary search, then, it is what it is. We got inceptioned. Okay. Today's problem is 1052, Grumpy Bookstore Owner. There is a bookstore owner that has a store open for n minutes. Every minute, some number of customers enter the store. You're given an integer array customer of length n, where customer sub I is the number of customers that enters the room at the start of the ith minute, and all these customers leave at the end of that minute. On some minutes, the bookstore owner is grumpy. You're given a binary array grumpy, where grumpy sub I is 1 if the bookstore owner is grumpy during the ith minute and 0 otherwise. When the bookstore owner is grumpy, the customer of that minute is not satisfied, otherwise they are satisfied. The bookstore owner knows a secret technique to keep himself not grumpy for consecutive minutes, but can only use it once. Return the maximum number of customers that can be satisfied during the day or throughout the day. Okay, so you have these customers, you have you can maybe this isn't binary search. I think the idea behind this one is probably going to be, I want to say sliding window, but I am kind of like I said, I'm just thinking about binary search for some reason, but I don't really see a very natural binary search. The thing that makes me lean toward a sliding window is that minutes is for 3 minutes, and you have the beginning of a window, you have the end of the window for those 3 minutes, and then the idea here is just that, okay, this is grumpy things, right? And then you just kind of get the sum of these customers, right? So, okay, so then the idea that I would have, and maybe, so I guess this is not binary search, or maybe there is a binary search, I don't know. But my instinct for right now, for today, is not going to be binary search. The thing that I would have is just, yeah, I mean, there are a couple of ways you can break it down, really, which is that, okay, so let's say we have these customers, right? And you have the grumpiness thing, right? And then here, then you can probably do some maths. I mean, there are a couple of ways you can do this, right? As long as you are consistent with your math and your methodology and your programming and implementation, everything should kind of match up. For example, one way that you can think about it is that you have a sliding window on the grumpiness, right? Which is, for example, this one is going to be 3. Then you can effectively say, okay, let's say our current window is this component, right? From here to here, right? 3 minutes. So then here, you can say that this is the sum of all the ones that are after this and before this, that contains, wait, is 1 grumpy or is it? So you want it to be 0, so the sum of the zeros. Sorry, the binary thing is a little bit weird actually, but so the sum of the zeros. So that let's say you look at this element, or this is your window, then you're going to sum 1 and 7 because zeros are there, and then the prefix of 0, right, which is 1. So of course, then you could solve this part. So now you have 2 queries, right, which is the prefix. You have everything to the left, which is 0, sum that, and everything to the right, which is 0, and sum that. And then you can, sum the interval in between. And that part is just sliding window. So then you can break it down into 3 components, right? Like I said, sum the prefix to the left sum the suffix to the right. And of course, these are the where the grumpy is 0, right? So both those cases hopefully make sense, right? And then we just sum everything inside the interval. So that's one way to do it. Why not? Wait, yeah. Okay, yeah. So I'm just double checking the end. The way that they write this was kind of weird, but okay, fine. Yeah. And then another way that you can think about this is just that you have the sum of all the zeros for the entire thing, right? So now this is method 1, say. I just kind of am giving out random ideas, and you could probably do more than this, but I just want to give an idea that, hey, you're not stuck by one way. Sometimes I solve this problem, and maybe I've done it before. Yeah, wow, 5 years ago in C#, because I just like doing random stuff. Maybe we'll take a look at it. But yeah, sometimes I get questions about like how to do it in the right way, but mathematically they're equivalent, then it doesn't really matter, right? For example, here you could, like I said, sum the left, sum the right, and sum everything inside the interval. The other thing is sum all the zeros through all the thing, right? In the entire array, and then now the sliding window will sum the ones in the window, and that's it, right? Because then now it's just everything plus whatever's inside that. The delta, the difference, is going to be just the ones that goes to 0, meaning that you now get to sum the ones that are inside. So that's another method as well. And then obviously, as you slide, you take the best, right? So these are two ways of doing it. And once you think it through, then you can think about which way is easier. Method 1 requires setting up for prefix sum and also a prefix sum on the inverse. I guess suffix sum in a way, though that has different connotations. That's why I didn't say it that way. And then also summing inside the interval. That part's a little bit easier because that is just sliding window, right? You keep everything inside the window. Though, of course, you can also use prefix sum for it if you like, but it is another setup. Method 2 seems more straightforward for me for now, right? You sum all the zeros, right? All the elements that are 0, and then sliding window just sums to 1, which is very easy to slide through. So I'm going to choose method 2 for the way that I'm going to implement it. So yeah, and I talk a lot, and sometimes halfway through I'm like, oh, maybe I messed this up. So hopefully the implementation hopefully I read this correctly, is what I'm saying. Yeah. Because sometimes I just misread the problem, and then, and then it's sad. But yeah, okay. So then now what does the window look like, right? So then window is just for, I guess, let's say this is right. And in this case, because the window is fixed, and we talk about sliding windows and contributions and all these things. So left is always going to be just right minus minutes, right? Maybe plus 1. Maybe I'm a little bit off by 1, right? But so we can just implicit it out, right? Or we can define it inside. So then now, let's say okay. Oh yeah. So total. So I guess we have to kind of go for a loop first. So we have total is 0. Let's set the best up real quick, and then total we have this, right? So if grumpy sub I is equal to 0, total we added to the happy customers, right? Otherwise, afterwards, then now maybe it's more accurate to do best here, right? And then maybe now you have the current, and current is just sum of ones inside the window, because those are the things that we're changing, right? So then now here we go, if grumpy sub right is equal to 1, then we add the current, right? Because then now everything inside this window is happy. And left is equal to, say, right minus minutes plus 1, I want to say. Sometimes I'm off by 1, that's why I'm not super confident. But it should, I think this is right. It's just, because for example here, no, because left is inside. So this is true for the left border for the inside, but then we want to subtract out the one that's outside, right? So it's going to be right minus minutes. And then if left is greater than equals 0, because otherwise it falls off, then current we subtract it from customer sub left. And then now the window reflects. Oh no, this is wrong. This is well, I mean, this is a little bit sloppy wrong, which is that it has to also equal to to 1 rather, whereas grumpy. Because otherwise, if it's 0 drop off, we already factor that in. We don't need to do it, right? And then now we can say that now we try to calculate the current total, which is total plus current is the current score, because total is all the zeros outside of the sum, and then or including inside, actually just total over the entire thing, and current includes all the new ones that are turned into 0. So then now we can just maximize over this, and then that should be good, unless I misread the problem, which hopefully not, because I'm be a little bit sad. But let's give it a submit, and yeah, looks pretty good. 15 4-3-day streak, whatever that means. A little bit slow apparently, but I don't know. I'm confident about it. I mean, this is going to be linear time, linear space, right? So pretty straightforward. Kind of surprised it's a little bit slow, but even my C# stuff, unless there's like a really obvious thing that I'm missing. I don't know. Maybe we'll look at the answers then. Let's look at. Well, C# is going to be faster just in general. And how did I do it? How did Larry of 5 years ago do? Oh, let me actually, before I do that, let's go over the time complexity. I did kind of mention it. I did skip over it too quickly, which is that this is linear time and constant space, right? I mean, linear time because we have 2 for loops. Constant space because we only have 1, 2, 3, 4 variables, 5 maybe, or something like this. I don't know, whatever, right? Constant number of variables, and yeah, that's all I have for this solution. Let's take a look at 4 years, 9 months ago Larry. That Larry was happier and all these other things, but I don't know. Okay, so we did take the sum, and then what is this delta for? Oh, this is up to X. Did they call it X back then? I don't think I. Maybe they renamed the variable, because that doesn't seem like me to kind of just have a random X variable. Though maybe I'm wrong. But either way, so the only thing that's a little bit different is that I structured it a little bit different, which is that. Oh yeah, first max is the equivalent of best as today. Because I think max is just a function name in Python, right? That's why we don't call anything that. But in any case, yeah, this just sums up the first X elements, which is the first minutes. So then you kind of get the score you update, and then it just starts from there instead. Basically, we did the same thing. So good job, Larry from 5 years ago, who is less practiced at that time. But yeah, and I didn't C#, so I don't know. There was time where I was taking requests on languages, but yeah. Cool. That's all I have for this one for now. Yeah, let me know what you think. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord, hit all the buttons. Stay good, stay healthy, to good mental health. Stay cool if you're in a very hot area like I am now. I'll see y'all later and take care. Bye-bye.